Okay, so in this video, we'll be using the sine ratio to solve some questions. And how I'm actually doing this is just basically revision, so you can remember how to go about and solve these types of questions. So let's now get into the gist of what exactly you're focused on. Now remember, for the sine ratio, you will be given a right angle triangle. And in looking at the triangle, you'll need to actually come up with an elimination method, let's say. So let me write out all of the formulas here and you'll see that me do this for all of the videos. It's me trying to help you to understand how you go about understanding which of the trigonometric ratios you need to make use of. So sine theta, which is opposite over hypotenuse, cos theta, which is adjacent over hypotenuse, and tan theta, which is opposite over adjacent. Good. So once you understand that these are your ratios, which you will need to memorize, you will need to now try and look at the question and see which one of the ratios apply. So we're solving for the side BC, which I'll put a question mark here for that. Now we have the hypotenuse, and we have this angle here at A, which is 62 degrees. So in drawing our line over here, it seems that it would indicate that this is the opposite, leaving the bottom here to be the adjacent. So with that being established, we now look at our ratios. We have the hypotenuse. We're given the hypotenuse, so we cannot use tan, leaving us with cos, cosine, and sine. Noting that we need to look for the opposite, then we don't need to use cosine, leaving us to use the sine ratio. Therefore, sine theta, which is opposite over hypotenuse, will give us that sine of 62 degrees is equal to the opposite, which is BC, because remember, we're told we are looking for BC, and our hypotenuse, which is 44 meters. Just a moment. I'll just have to scroll this across. Good. So with that now being established, our next step is to transpose. Now generally you will be taught different ways on how to actually do this, but we're just going to say we're carrying this over. So as it's in the divisor position, we're actually going to use it to multiply. So sine of 62 degrees times 44 meters is equal to BC. So with this here now done, we can now use our calculator. So I'm entering sine 62, enter. So I want this decimal, then I'm going to multiply it to 44, and it gives me 38.849. So I'm going to use one decimal place, which is 38.8 meters is equal to BC. Good, so that's one question. Now, okay, so now let's look at the next question here. We're told to solve for the length of the side QR. QR is our diagonal. So let me put a question mark here. And we'll notice that this is our hypotenuse. Good, so we draw a line across from where the angle is given, indicating to us that this is the opposite, and this is the adjacent. So our sine theta, which is opposite over hypotenuse, our cos theta, which is adjacent over hypotenuse, and our tan theta, which is our opposite over adjacent. So notice again, we have the hypotenuse we're going to solve for, so we don't need tan. And as before, the adjacent is not what we're looking for, leaving us with our sine ratio to be made use of. So notice how I'm actually going through this elimination method. This is something you need to practice because, again, they're all three ratios that are given to you for you to learn. Any one of them could come in a quiz or at CXC. So let's now continue with our sine theta being equal to opposite over hypotenuse, giving us our sine of 33 degrees is equal to our opposite, which is 17, divided by our hypotenuse, which is going to be QR. Therefore, sine 33 degrees times QR is equal to 17. Notice we need QR to be the subject. Therefore, QR is equal to 17 divided by sine 33, which is going to give us, we run to our calculator, we enter 17, division sine of 33, giving us 31.2 as the answer. So notice in this question here, we had to solve for the hypotenuse, which required for us to actually do a little bit more work in order for us to arrive at our answer. Okay, so now we're back here. So let's me set this up first. Sine theta, opposite over hypotenuse, cos theta, adjacent over hypotenuse, tan theta, opposite over adjacent. So just take a moment, if you want, you could just pause the video and see if you could figure out which of the ratios to make use of. Of course, it's all sine, but of course I want you to just practice the elimination method that I've been going through throughout this video. So, okay, so let's now continue. The diagonal is our hypotenuse. Here would be our opposite, leaving us here with the adjacent. So from right now, we know that tan is going to be out. And since we're solving for the side labeled A, which is indicated there, we know it's the opposite. As we have both the opposite and hypotenuse, we'll use sine theta. So sine theta, opposite over hypotenuse, sine of 30 degrees is equal to our opposite. In this case, we have the letter A, and our hypotenuse is 15 feet. Sine 30 degrees times 15 is equal to A. So sine 30, then we multiplied 15, giving us 7.5 feet is equal to A. So notice, like before, we transposed the 15 feet to be multiplied by sine 30 degrees, and then we just had to go ahead and solve. Alright, so we're almost finished. We just have 2 more questions to go through in this video. Now this is the side that's labeled G, and notice it's the diagonal, so it's the hypotenuse. Drawing our arrow, we can clearly see that this is the opposite, leaving here to be the adjacent. So clearly, from this point, you should be able to recognize that you have the hypotenuse and the opposite. So writing it out, sine theta, opposite over hypotenuse. Now our sine of 42 degrees is equal to our opposite, which is 9 feet, to be divided by the hypotenuse, which we have as G. So like before, G is going to be transposed to be multiplied by the sine of the angle. Therefore, sine 42 degrees times G is equal to 9 feet. So G is multiplying sine 42. So what we're going to do is we're going to take the sine of 42. Since it's multiplying, it's going to go over and divide. So G is equal to 9f over sine of 42 degrees. So therefore G is equal to 9 dividing sine of 42, giving us 13.45. So this 13.5 feet. Okay, and here's going to be the last question. We're solving for the side AC, so I'm going to put a question mark right there, or diagonal. Now, before I move on, let me just highlight one more thing. Notice wherever you have your 90-degree angle, what is opposite, that is going to be your hypotenuse. So that's just a simple indication, but also remember that it's also always going to be the longest side. So there's our hypotenuse. Our angle is here, 75 degrees. Let me just erase this unnecessary. Yeah, it's 75 degrees. That should be there. Good. So hypotenuse, we go across here. It's our opposite, meaning this the adjacent. Good. So sine theta, which is our opposite over hypotenuse, sine of 75 degrees is equal to our opposite, which is AC, to be divided by hypotenuse, which is 26 meters. Therefore, as that's there, we're going to take it over and multiply. Sine of 75 degrees times 25 meters is equal to AC. Therefore, sine 75, which is then going to multiply 25, is equal to 24.1 meters is equal to AC. So that being said, we just went through 6 questions as it relates to using the sine ratio. Look forward for videos on the tan and cosine ratio as well. Remember, these are revision videos before we actually get into solving for angles of elevation and depression.